Okay, guys. So let's start over chapter 2, part 2. So in the first part, we discussed the definition of computer and we discussed different types of computer. Today we're gonna actually discuss the computer architecture, and specifically we have three things to discuss today. Starting with the definition of processor, we'll discuss the working of processor, machine cycle, and stuff like that. Then we will discuss memory in detail. We'll discuss different aspects of memory and what are the different, the hierarchy of memory as well. Lastly, we'll discuss optical drives, the role of optical drives, ports, and different types of connectors. So let's start with the processors. So the first agenda item is processor. Processor, or we call it CPU. CPU stands for Central Processing Unit. So CPU is basically the brain of computer. The main, or you can say most important component of computer is processor, CPU, and it's also called brain of the computer. CPU, it mainly has two components. Mainly it has two components. One is called control unit, CU. CU is the abbreviation, and second is arithmetic logic unit, ALU. ALU is the short form. So basically, if you see CPU, let's say this is your CPU chip. So CPU has two main components. One is control unit, second is ALU, arithmetic logic unit. So what are different aspects of what exactly CU does and what ALU does? So basically, control unit, what it does, this is, let's say this is your CPU, and before the CPU, and that's the CPU chip. In fact, as I mentioned earlier, it has two components. So before the CPU, we have another component which is called RAM, random access memory. We'll discuss RAM in a while. And let's say this is your, for example, let me just give you a basic idea about how CPU works and all that. So for example, if you have a software, so you have a software application. And as you know, what is a software? Software is nothing but it is basically set of instructions. So that's the definition from chapter 1. So software is basically set of instructions. For example, let's say Microsoft Word. So Microsoft Word, if you install Microsoft Word, or let's say if you execute or run Microsoft Word on your computer, so that software has set of instruction. Those set of instruction will tell the compiler or ALU how Microsoft Word, this particular program will work. So what will happen when you run the software on your computer? These set of instructions will be loaded inside the RAM. Let me repeat. Let's say if you open a Microsoft Word file. So what happens? Once you run the software, set of instruction that how Microsoft Word is going to be executed, these instructions will be loaded into RAM. So see, and again, in order to execute, in order to in order to run that, we need to actually use CPU. CPU execute or make it functional. So instruction loaded into RAM. Control unit, it does two main things. It actually fetch instructions from the RAM. First step, it fetch instructions. So it fetch instructions from the RAM. After fetching instruction from the RAM, then its second step, it decodes instructions into commands. So CU, this control unit, it fetch instruction from RAM which got loaded from software, and after fetching instruction, the decode instruction, understand instruction, and make them command, because ALU does not understand instruction. It says I need command. I mean, I don't know what this instruction says. You need to tell me. So ALU, what it does, it execute commands or whatever the required task is. And after executing, it also, you can say, give output, or you can store that data as well. In fact, if you want to define what ALU does in execution, it performs mathematical computations. So all the mathematical computations are performed here at ALU. So let's move on to a machine cycle, because if you understood this particular figure, you can easily understand machine cycle. So machine cycle is how basically a CPU works. So four main steps. The first step is fetch instruction. Like CPU, what it does, it fetch instructions from RAM. After fetching instruction, it decodes instructions. After decoding instruction, then it execute instructions, and then lastly store or give output. So these four steps, please remember in a sequence, because that's very important from quiz point of view. These first two steps are basically performed by control unit. The last two steps are performed by ALU. So these four steps are called machine cycle, like the working of CPU. Next is a definition of clock rate, clock speed. This is very important definition. Let me define it, and then I'll explain to you what is basically clock rate and speed. So clock rate is basically the speed at which processor performs the operations required to run a digital device. So this is called a clock rate, or you can say clock speed. Another definition of clock rate or clock speed is, which is more technical definition, it is called number of instructions executed by processor in 1 second. So basically, if you see, this is your CPU. Okay, that's your CPU. As you know, CPU has two component, control unit and ALU. So what we are basically giving input to CPU? We are basically giving instructions. So number of instructions this CPU can execute is called clock rate or clock speed. It depends upon a frequency, and that frequency is basically in hertz. And you can also see your clock rate as well. If you pull the properties of your computer, you can see the clock rate, what clock rate your computer might have, and it should be in hertz. Hertz are the units of frequency, which is equal to cycle per second, or you can say instruction per second. Let's say most of the your clock rate is measured in hertz. Okay, first of all, hertz, Hz, hertz, units of hertz. And most of the computers, they might have 2 gigahertz to 4 gigahertz. That's basically their clock rate ranges. So 2 to 4 gigahertz are basically the typical PC clock rate, personal computer clock rate. So 2 gigahertz giga is basically a billion. So it's like gigahertz mean billion instructions per second. So it means if your processor has 1 gigahertz, so it can actually execute 1 billion instructions per second. If it would be 2 gigahertz, so it's going to be 2 billion instruction per second. Let's say if your processor is 1 megahertz, then it means 1 million. Mega is for million. 1 million instruction per second. Okay, but usually it ranges from 2 to 4 gigahertz. Other than that, the speed of processor is processor based on two things: clock rate, clock speed or clock rate, both are the same things, and bus width. We'll discuss that in our last part. What is basically bus width? Okay. So that's, I guess, pretty much is about clock rate. Another very important concept is called overclocking. It's not a normal concept or normal phenomena, but overclocking is basically most of the gamers, or you can say developers, they actually go for overclocking. Overclocking, the definition, overclocking is basically, let's understand first. Let's say your CPU has 1 gigahertz. That's the clock rate. So what does it mean? 1 gigahertz mean it can execute 1 billion instructions per second. So it can easily handle that because it is designed to handle 1 billion instructions per second. So but for example, let's say if we start pushing 3 billion instructions per second, it's basically designed to handle 1 billion, but you're basically pushing more instructions as compared to what it designed for. So that's called overclocking. Overclocking is a cheaper way to actually get more stuff done, or you can say to efficiently utilize the resources, but it can void your warranty as well, because processor can heat up and all that stuff can happen. So overclocking definition is running a processor faster than recommended by manufacturer is called overclocking, or it will result in overclocking. And please remember, overclocking will void your warranty. So manufacturer warranty will be voided. Other than that, it can actually cause heating. That's why some people actually use some, the cooling pad, the cooling, the pads and all that stuff. Another concept about processor could be multi-core or single core. Single core or one core means a processor has one ALU plus one control unit. So if processor has just one chip, one control unit, one ALU, that particular processor is called single core processor. But nowadays we have multi-core processors are coming in, and multi-core processors are basically CPU with two or more cores. So CPU with two or more cores are called multi-core processors, and multi-core processors use concept, please remember that, hyper-threading for execution of instructions simultaneously. So what does it mean? Let's say this is your multi-core CPU. So this is one chip, this is second chip. So let's say this is 1 gigahertz and this is also 1 gigahertz, and you got, for example, 1 billion instructions. Okay, so now what's going to happen? So we will use the concept hyper-threading divided here. What it will do, 500 million instruction will be executed from this processor, instruction will be executed from this processor, and then you will have the faster output. Rather than executing all 1 billion instruction from one processor, you can actually divide them. This concept is called hyper-threading. Okay, let's move on to memory. Memory is basically, you can say, it's the electronic device. So memory is an electronic, you can say, solid state device and has no moving part. So usually whenever you see a word memory, it means we are referring, or we're talking about random access memory, RAM. Access memory. Now what is basically a random access memory, if you need to recall this? So whenever you actually execute any software, its instruction get loaded into RAM. So RAM, in fact, it actually holds the data or the programs which are currently being executed. So you can say RAM holds the data or programs instructions which are currently being executed. So that is basically called RAM. So for example, if you open let's say a website, so that particular web page is basically stored in your RAM. So RAM is a temporary storage. When device is powered off, then all contents of RAM will be cleared, will be deleted, or you can say cleared. So let's say if you turn off your computer everything which was inside the RAM, it will be deleted or it will be gone. This is just a hierarchy of the memory because typically a computer should have 4 GB RAM. So 4 GB RAM is required for smooth functioning of laptop, or you can say personal computer. Let's say if you want to run the modern software or the applications, you need to have at least 4 GB of RAM. So this is basically, I'll start with 1 KB. Let's say kilobyte is the smallest unit. It is basically 1000 10 raised to power 3. Next is the MB. 1 MB is 10 raised to power 6. Then we have next is GB, 10 raised to power 9 billion. The next unit is basically TB, terabyte, 10 raised to power 12. Next unit is basically PB, petabyte, 10 raised to power 15, then zettabyte, etc., etc. So that's basically the hierarchy of a memory. Next is cache. It's also a very important concept, and nowadays it is the mandatory component which comes with the processors and memory even as well. So cache is basically, you can say, in addition to RAM, modern processors temporarily keep frequently accessed data in cache. Okay, and usually cache is located directly onto CPU. So basically, if you see down here, this is your processor. So what you are getting? So basically, each time you're basically fetching instructions from the RAM. Okay, so it takes some there's a transportation delay each time. So why don't you have a small and the faster memory? Right, it's because cache is very small and faster. So please remember one thing: is something is small, automatically it will be faster. Why is it will be faster? Because if it is small, it has less capacity of the data. And if you're trying to search a specific data, since the size is small, so it will take less time to find it out. For example, let's say you live in a 1-bedroom apartment, and you are basically looking to find, you lost something. So it will take less time to find that particular item, rather than if you live in a villa where you have 4 or 5 bedrooms. So if you have a small, place to find a specific item, it's faster. So in the cache is directly located onto processor, and we actually, for example, if you keep doing the same things again and again, so we actually hold that particular instruction in the cache rather than fetching instruction from RAM. Processor can get the instructions from cache. Okay, that's basically what cache is for. So let me repeat. Cache is basically a memory which is directly located onto processor, and it holds the recently fetched or recently executed or frequently accessed instructions. So you don't have to go back and get the instruction from RAM. If same program is running, you can actually get instruction from cache. So cache can be of 2 types mainly. First is called memory cache, which we are talking about. Second is called disk cache. Memory cache can be further classified into 2 types, L1, L3. So these are the 2 types of cache, L1 and L3. L1 is basically, which we are talking about, directly located onto processor. It is directly located onto processor, very small. L3 is basically slightly bigger than L1. It's like 32 KB or something, slightly bigger, and located in between CPU and RAM. So something like that. This is your CPU, this is the RAM, this is your L3, and L1 is directly located onto it. So, and it holds slightly more instructions as compared to L1. So firstly, what happens if CPU wants to fetch instruction? Firstly, it will try to find instruction from L1. If it didn't find instruction, then it will go to find instruction with L3. And if it couldn't find instruction from L3, then you will contact to RAM, otherwise not. Disk cache is basically located onto hard drive, your hard disk, and it basically stores the address of frequently fetched data. So if you access or fetch the our data, quite often, so the address will be stored in that disk. You don't have to actually find the address again and again. Next is the ROM, read-only memory, and read-only memory. Although its name is memory, but actually it is a storage. Why it is a storage device? Because it retains data even you shut down computer, just like your hard drive. What it actually holds, it holds the instructions needed to boot up a computer, such as BIOS, like basic input output system. It's typically stored inside the ROM. ROM is basically installed by manufacturer, so you cannot actually modify the contents of ROM, in fact. The next is the optical drives. Optical drive are basically the slots where we insert DVDs or CDs to write, to watch. Let's say if you want to watch DVD or CD, it's basically we need to insert them in optical drives, and they use laser lights to read and write the data onto the disk. So optical disks are basically drives that can read, or you can say write, data onto disks, optical disk, using laser light. They use laser light in order to read and write the data. So when you just insert a DVD, or you can say a disk, inside the optical drive, what happens? It actually it started rotating, because data is written in the form of tracks. So let's say this is your disk. So data is basically written in the form of tracks. So let's say if you want to listen track number 1, so there will be a head. It will move on and placed right onto the track number 1. Once you forward this track number 1 and you want to listen track number 2, your mechanical arm will move onto it through a laser light and start reading it out. CDs are the example. CD stands for compact disc, and the size is 700 MB. Then we have DVDs came in, digital versatile disc. Versatile disc, and digital versatile discs are basically size is 8.5 GB. Then we have Blu-ray nowadays, and the size of Blu-ray is 50 GB. You can make Blu-ray just readable, or you can make it rewritable. So if you make them rewritable, so what's going to happen, like it will become just like a USB drive. There are two terms which are closely related to optical drive. One is called burning. Burning means when you write something onto disk. So writing data onto disks, it is called burning, while ripping is copying data from disks. This is called ripping. Then we have ports. Ports are basically a point, or you can say hole, in a computer designed to accept a specific connector. You might have you have seen many ports in your computer, like Ethernet port, where you can put the Ethernet cable, USB port, etc., etc. So computer can communicate with external components like peripherals through these ports. Okay. Last thing for today is the connectors. Connectors are basically the code end cord and that connects to a port. So there are many different types of connectors. Like the most widely used type of connector is USB Universal Serial Bus. This is the most commonly used connector for connecting peripherals, and we use this for data transfer, electrical charging, etc. So since it is very reliable, USB, these ports are very reliable and inexpensive. So because of inexpensiveness and reliability, these thumb drives, or you can say thumb drives, which goes in the USB port thumb drives, or you can say USB devices, have become extremely popular storage devices. So these are much more you can say reliable as compared to even your optical disc as well. Lightning connector is basically it's called basically firewire connector that comes with Apple products, and it's basically used for fast charging as well. HDMI, I believe everybody heard about HDMI, high definition multimedia interface. High definition multimedia interface. So it is the standard port for video or audio input to TV or projectors as well. You can connect your computer or your device with the projectors as well, multimedia projector. MIDI is basically musical instrument digital interface. So MIDI ports are basically used to connect your your musical instrument with the computer. So connecting the digital musical devices to computer, like your guitars, violins, pianos, etc., etc. Okay. So that's it for today. If you have any question, we can discuss in the online session.